Hello, good afternoon, or good morning. Today is October the 24th. That's not right. October the 27th. It is the end of the quarter. It is Tuesday, and is the beginning of a new unit. And this unit is not about political history. It is not about leaders, political leaders. It is not about culture. It is about man's intellect, the evolution of thinking. And, the age of science and the age of enlightenment is probably one of the most, if not the most, important intellectual periods in the history of mankind. For the very simple reason, and trust me, the age of reason is not perfect. The philosophers were not perfect. But it was a step forward. Because the age of reason came about with this idea that you should not simply just accept information that's given to you. You should test it for yourself. You should learn. You should have an organized method of experimentation. You should trust the science. Where did I hear that? But anyway, and so yes, this is about the age of science, the age of and then the age of reason, which are two separate entities. And yes, there we go. Excuse me. So, where did I go? Yes, here. I'm in the wrong place. This is disturbing. There. Yes. So, it's a very long unit, as you might have seen, 26 pages. And so, yeah, this is going to take a while to get through. And I trust that everybody here, well, not everybody, but about 60% of you, 70% of you, have had the opportunity to enjoy fresh Horton over canned Horton. But we always have canned Horton for the days when fresh Horton is not available. So, the age of science and reasoning. As it says there, it is an overall acceptance of what we today call science. And by the way, as will be mentioned later, the term science and scientist will not even be used until the latter part of the 19th century. So, what we call science, what the Greeks call logic, that finally put an end to the age of faith, or for lack of a better term, the Dark Ages, and brought about the age of reason and the Enlightenment. For what it is worth, look at there. The term science was not utilized to the 19th century. Prior to that, science went by many names: natural history, what we would call biology, laws of nature, scholasticism. Natural, yes. This unit is the first of several of this course, which covers what is called intellectual history. That is the history of Western European thought. And the mainstream history courses, it's a neglected field, but we cannot afford to make that oversight. Why? Well, one reason is that, and this may not apply to you, but then it might. This past summer, for example, I read in the AP reading, and I was a reader for 6 days. Of those 6 days, 5 of them were spent reading a question about the Enlightenment. Yeah, and I'll be straight away. It's not the most riveting thing, but and my students don't find it riveting. Fortunately for my students, many of whom had to take that question because in the way they do, You don't have a choice. You are given a question by random. A number of my students had to take that question, and a number of them had to answer some question about the evolution of the Enlightenment using 5 documents. And by the way, I have to admit that of those 5 documents, I recognized one name of them. Yeah, one name of the Enlightenment, and that was Voltaire. But yeah, so the Enlightenment is worth knowing. All right, so they were often referred to as the cunning folk, and we're talking about now this is the age of science, the beginnings of the age of science. Remember, there was no such thing as scientific pursuits. Were no laboratories in the Middle Ages, 12th, 13th centuries, 14th centuries, per se. There were no divisions of the sciences, no divisions of fields of study. If you wanted to study something, you studied everything you get your hands on. Astronomy, mathematics was the big one. Histories, what we'd call biology. And in fact, most of the early scientists were members of the clergy, members of the priesthood. You say, well, why is that? Wouldn't they be against that? To be honest, members of the clergy were the only people in society, European society at that time, that could spend hours and days researching questions that had no direct benefit to the common folk. For example, the first real astronomers, people like Copernicus, Tycho Brahe, and Galileo, and others like them, they didn't have telescopes. Well, Galileo invented one, but they didn't have telescopes largely. And so when they would study the stars, they would, of course, go out at night and they would stay all night outside, and they would find a location either on a hillside or on top of a house. And what they would do night after night after night on clear nights, and if it's raining, cloudy, which it often happens in Europe, you can't do this, but they would set an easel down and they would diagram the stars in the sky, and they would set it in the same place every day. So, in other words, you have the same view. And they would diagram the stars in the skies. And what they began to notice was that they moved. Now, that wasn't so surprising, but what was surprising was the patterns with which the stars moved across the skies over periods of weeks and months didn't make sense. They didn't suit the idea that the Earth was the center of the universe and all the other planets simply just went around in circles around it. It didn't make sense at all. And so, yeah, that's kind of the beginnings. But the biggest point of the matter is that you want to know is that the early scientists were real amateurs. There were people who did this in their spare time. They weren't really, credentialed of that, so to speak. They taught themselves. All right, and so once again, they were often referred to as the cunning folk and looked upon with great suspicion by not only those who obviously knew less than they did, the townsfolk, but also they were looked upon with suspicion by those who were supposed to know more, that being the church, Roman Catholic Church in particular. They were the practitioners of what in popular terms was low-level magic. For example, as we're about to see, interestingly enough, many modern fields of science had their humble beginnings with such individuals. The field of astronomy actually began as astrology. Now, you're going to need to know what both those words mean: astronomy, astrology. Astronomy, I hope you understand, is different. Astronomy is the academic study of celestial bodies and their movements. Science. Astrology is instead a pseudoscience. P.S. UEDO, pseudo-science. The word pseudo means false. Astrology is the belief that the movement of the heavenly bodies have an effect upon the lives of people on Earth. Come on, have you ever read your zodiac or anything like that? Well, that's from astrology. The moon is in the seventh house, and Jupiter aligns with Mars, and peace will guide the planet, and love will steer the sun. This is the dawning of. But the field of astronomy actually begins with astrology. I mean, that's where the first real observations that were recorded about movements of the celestial bodies, and people read those over time. Modern medicine can trace many of its roots into what we would consider barbarous witchcraft today. Yeah, yeah, and not lying either. I mean, a lot of the things. Alchemy was the background for chemistry, and the word alchemy is on your test. Does anyone know what alchemy means? Mr. Blackburn. Alchemy. Mr. Leroy. Alchemy, once again, pseudoscience. Alchemy is the attempt to try to change base materials such as lead, egg yellows, various and sundry other materials into gold. Yeah, people did that, tried that for a long time. Actually, it's possible. You can change other elements into gold. Problem is the process whereby because gold is just another element that has a certain number of protons, neutrons, and electrons. And you can change the numbers of protons, neutrons, and electrons in an atom. Problem is, it's really costly. It would actually be more costly than gold is worth. So, no. Hermeticism is the magical belief, which came from the ancient world, in the magical power of knowledge. People thought that people who had knowledge also were magical. Yeah. There were authorities on higher learning that we might look upon as scientific, but these were often mistaken. For example, for the longest time, popular belief, which was supported by the Roman Catholic Church, supported the idea of the Greek philosopher Galen on the circulation of blood. Galen was a Greek philosopher who made educated guesses about blood, for example. And those guesses were that blood is manufactured in the liver, which it is, and then pumped by the heart out to the extremities of the body, which it is. But what Galen could not know was that through capillaries, which are so tiny they can't be seen or observed, the blood then returns to the heart and the lungs, and then is regenerated with oxygen. Galen couldn't see that. But it also gave the idea that if someone were sick, like the dirty oil that's in your car, the best way to cure that sickness is to drain off the dirty oil, a process known as bleeding a person. Like I'm sure Miss Perkins could tell you happened to George Washington. Yeah, George Washington died in 1799 of a cold. Of course, not of a cold. He died because he got a bad cold, and doctors they did the worst thing back in 1799. They did the worst thing for George Washington you could do when a person was sick, and that was call a doctor. They didn't call one doctor; they called three. And they did all kind of things to him. For example, they put a poultice around his neck, which, they gave him some hot tea to drink, which actually is a good thing to do, except he was so congested he choked. almost. Then they began using their scientific knowledge, and once again, keeping the idea that there's something dirtying his blood, we need to drain it out. First thing they did was to induce diarrhea in the man, and by giving him something to drink, and it had its effect. It induced diarrhea, all right. Problem is with diarrhea, dehydrates you. In other words, it takes the water out of your system. And then after they did that, they bled him not once but twice. The second time was too much. And yeah. But you say, Mr. Horton, what does that do with anything? Well, they were using Galen's theory that the blood doesn't circulate. It doesn't circulate through the body. It goes one way. Galen thought that the blood came from the liver and the heart. And then when it got to the extremities, the body consumed it. So draining it off shouldn't be a problem. So, or Ptolemy's ideas about the orbit of the sun around the earth. And I did say that right. This is called Ptolemaic astronomy, also called geocentric astronomy. Geocentric, geocentric, the belief that the earth is the center of the universe. People like Aristotle, Galen, and Ptolemy were called natural philosophers. They were given credit for being smarter than they actually were. During the Renaissance, though, and the age of reason is a natural offshoot of the Renaissance. The age of science and reason was a natural offshoot of the Renaissance, was a natural offshoot of the Reformation, the questioning of established beliefs. But during the Renaissance, many people began to question the findings of the Greeks, and who had been accepted by the Roman Catholic Church. Now, that was the problem. The Roman Catholic Church, for some reason, they rejected everything else Greek and Roman. Plays, theater, taking baths. But they accepted these ideas that the Greeks had about, for example, the circulation of blood. And, for example, the constellations in the sky, the Earth-centered theory of the universe. They accepted that. And here's the bad thing. Disagreeing with what the church thought could get you in the soup, right, Galileo? Right? So, Renaissance painters even made contributions to the logical inquiry of the natural world by strongly suggesting that its practitioners learn about that world. You say, what does that mean? It means Renaissance painters said we need to learn about the earth we're living in. And we need to learn beyond what we're being told. Da Vinci, for example, designed war machines. Albert Dürer made designs for fortifications of cities. Albert Dürer was a painter of the Northern Renaissance, painted a series of self-portraits. Hermeticism is, once again, the idea that knowledge has power. Okay, the 15th and 16th century saw a rapid expansion in the number of books that were being printed. Thank you, Johann Gutenberg. And these books, many of them were dedicated on how to build stuff. You see, once again, the printing press is the greatest invention of the last 1,000 years. I don't care what Bill Gates says or anybody else. Printing press is the greatest because the printing press made knowledge cheap, made knowledge more available to more people. It spread ideas, including ideas of how to build stuff. You didn't have to learn from somebody who knew or, rumor. It's printed. It was preserved. However, many techs, in other words, people who got into the how to build stuff, did not see the necessity for scientific research. And that question, how does Dr. Sheldon Cooper feel about Leonard Hofstadter? Sheldon Cooper deals in string theory, as you might know. He looks down on Leonard Hofstadter, who does not deal in theory. New research devices like the telescope and the microscope did open the door for multiple discoveries. Pardon me, but once again, Roman Catholic Church was not a fan of these. In fact, we'll talk about Galileo in a little while, but in fact, Galileo, of course, comes up with several observations about the nature of the sun and the nature of the Earth's rotation revolving around the sun and things of that nature, which of course the church condemned. And not only did they condemn his findings, they threatened Galileo with excommunication and death by being burned at the stake as a heretic. And Galileo was forced to recant his findings. Only in 1992 did the Roman Catholic Church officially come forward and say, you know what, we were wrong about Galileo. Only 1992, Pope John Paul II, good man. So, mathematics, and you need to underline this, that's important. Mathematics was looked upon as a way of unlocking the mysteries of the universe. As it says there, all the great discoverers, Copernicus, Galileo, Johann Kepler, and Newton, were first and foremost mathematicians. Please don't tell my friends in the math department that. I mean, they're arrogant enough as it is. They think they know everything. Math is so hard. History, just learn a story and parrot it back. Anyway, Roman numeral 5. The first true inquiries into what we call science was in the field of astronomy. The first accepted authority on astronomy was that guy Ptolemy. Ptolemy, and you're right, see that line right there, left to right? Ptolemy was a Greek person who lived in Egypt in the days of the Roman Empire. So Greek, Egypt, Roman Empire. And he came up with this theory of the universe that he must have made just from, this is what happens, with what is called the geocentric theory of the universe. And that theory is simply that all planets revolve around the Earth, including the sun. And you know what? If you're just casually observing, it looks like it's true. I mean, the sun in the morning rises in the east, goes across the sky, sets in the west. Makes sense. The moon goes around the Earth, and the other planets, they do something, but nobody really paid attention to their patterns. Not right away. But Ptolemy, geocentric astronomy, became the official stand of the Roman Catholic Church. And that's called the geocentric theory. It held that all the planets, the sun included, revolved around the Earth in 10 perfect circles. Now, if you look on page 452 in your text, when it says, what was Imperium Heaven? Pardon me. The 10 circles, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, outside the 10th is Imperium Heaven. When you died, that's where you went. That was the belief. Why did the Roman Catholic Church accept that as true, since it came from a pagan? Because, for the longest time, the Roman Catholic Church held that anything that came out of Greece and Rome, and Ptolemy was a Greek person who lived in Rome, anything that came out of Greece and Rome, the Roman Catholic Church held was blasphemous, was a lie, was of Satan, and they tried to burn most of it, but they accepted. Not only did they accept the Ptolemaic theory of the universe, they defended it against other theories. Why? Because it fit in with their interpretation. And actually, if you look at the Bible, it refers to the four corners of the earth. It talks about man being the crowning creation of God. And since man is the crowning creation of God, then he must be at the center of the universe. And so it all fits. And that's why. Why did professional astronomers object quietly to this explanation of the heavens? It just didn't work. Meaning that these professional astronomers, they weren't professional. Many of them were priests who, like I said, had the spare time to get out on a rooftop or on top of a hill at night and to draw what the sky looked like from a certain perspective, night after night, and the patterns of the movements of the heavens did not fit into that. And that's why they objected, and they objected quietly, by the way, because once again, keep in mind that to go against the teachings of the Roman Catholic Church was one sure way to find yourself as the guest of a barbecue, burned at the stake, Mr. Burlew. Yeah, that's what it is. So, the first scientist / astronomer to gain note through his secretive studies, he had to keep it secret, was the Polish churchman Nicholas Copernicus. And those are the dates of his life and death. You have to remember them? No. I'm just, putting them in there because, and I've talked about dates before. I don't make you memorize dates. I think that's minutia, but you need to be familiar. You can't be saying, oh, Nicholas Copernicus was born in the 20th century, or even the 18th century. You gotta have a ballpark, So he wrote the book on the revolution of heavenly bodies, which talked about, the idea of the sun being the center of the universe and all the planets, including the Earth, revolving around it. He came up with what is called Copernican astronomy, also known as the heliocentric theory of the universe. Once again, there's a diagram on page 453 that shows his idea. It does place the sun at the center of the universe. It does place the Earth outside. It was flawed, in fact, by it retained that idea of perfect circles, that the planets revolved around the sun in perfect circles. That also didn't work. The first to attack this theory was actually the Protestants, because once again, it did not agree exactly with what the Bible said. All right, Tycho Brahe, and by the way, Copernicus. Regarding Copernicus's findings, number one, he didn't think they were very important. Number two, he did write them out, compile them into a book, and it was only a few months before he died that his friends persuaded him to publish the findings, publish the book, which he did. But the Roman Catholic Church didn't have enough time to read it and then hunt him down like they will Galileo. Plus, you have to remember that Nicholas Copernicus was a native of Warsaw, Poland. And getting to Poland was a lot more difficult than getting to Galileo Galilei, who lived in Rome. So, yeah. Tycho Brahe was another astronomer. The first part of his research life was spent on a Danish island where he sat there and night after night sit up in the upper part of the building and diagram the constellations. The first part of the second part of his life found him in Prague, in what is now the Czech Republic, as imperial mathematician. Remember, they're all mathematicians, to the Emperor Rudolph II. He took on a very famous assistant. That guy's name was Johann Kepler. Johann Kepler made many observations that combined the fields of mathematics, astronomy, and physics. Because once again, remember, these guys they're not pure mathematicians. They're not pure astronomers. They're not pure physics. Physicians, not physicians. Physicians are doctors. Kepler's laws of interplanetary motion, they are worth listening to. Number one, planets revolve around the sun in I like big words, not in a perfect circle, but in what is called an elliptical orbit. ELIPTICAL. An elliptical orbit. Elliptical means it's like an egg, shaped like an egg, with a large end and a narrow end. Now, law number two, that in the revolution of the small planet around the big planet, the Earth, for example, around the sun, The closer the Earth gets to the sun or any of the planets, the faster it travels. Okay. Closer it gets to the sun, faster it travels. And then finally, third, that there exists a mathematical equation describing the relationship of the distance of the planet to the sun and the amount of time it takes for that planet to make one revolution. You say, what does that mean, Mr. Horton? It means that it's always the same. It is exact. How long does it take the Earth to get around the sun? Answer, 365 days and a quarter. Exactly. That never changes. It's always the same. See, so there exists a mathematical equation describing the relationship between the distance between the planet and the sun and the amount of time it takes to complete one revolution. So, Roman numeral 9, perhaps the best known name of the age of scientific discovery, was almost quashed by the Roman Catholic Church and the Inquisition. His name, Galileo Galilei, who wrote several writings. Galileo worked with actually several things. Number one, yes, he was a mathematician, as they all were. But yeah, he invented the telescope. He made observations about not only the revolutions of the planets, but he also was the first person to see that the moon is not a perfect sphere. The moon has craters and deserts and mountain ranges. And he saw that with his telescope, which of course the Roman Catholic Church thought was some kind of witchcraft. And so, yeah, those are his books, Starry Messenger, Dialogue Concerning the Two Chief World Systems. Did Galileo agree with Copernicus? Not wholly. No, he did not. What does it mean to recant? Well, that's what Galileo had to do. You see, Galileo, rather arrogant, rather loudmouth, publishes his findings. Only Galileo lives in Rome, and so it's a lot easier for the Roman Catholic Church to hunt him down. And so they put him on trial for heresy. And remember, heresy is a very, very serious charge. You get found on the wrong side of heresy, not only will you die, you will die a horrific death. So Galileo had to recant, meaning he had to say, you know what, all that stuff I said about the sun and the stars, I was lying. All that research I did, that was bogus. Yeah, he had to recant. And then what's bad is, the church was not through with him. Yeah, they spared his life, but the rest of his life he spent under house arrest. Yeah, the man spent it under house arrest. And according to the legend, on his deathbed, he was supposed to have whispered the words, "But it does move," referring to the Earth and the other planets. Okay, now from Galileo will also come the scientific method, which I sum up very briefly there. You observe something, some phenomenon, you make a hypothesis, a guess about it, and then you begin experimentation where you prove or disprove the hypothesis. One of the early users of this system was a guy named Francis Bacon. Bacon comes up with a school of inquiry called empiricism, which means question everything. Yeah, Francis Bacon was a champion of what we would today call scientific research. And ironically, Francis Bacon died doing an experiment. He wanted to prove that freezing meat could keep it from spoiling. And what's bad is he actually proved it. He tried to prove it by stuffing chicken carcasses with snow, caught pneumonia, and died. Yeah. Then there was Rene Descartes, who said that all things should be doubted unless could be proven by reason. Cognito ergo sum. I think, therefore I am. And see, that is called the categorical imperative. I think it's, yeah, categorical imperative. I think, therefore I am. Meaning this, the whole essence of this age of science was to not accept anything. Not accept anything that you're told. Question everything. And so if you question everything, then how do you know anything's true? Well, and he thought and thought on this. And so he finally came up with this idea. If I'm thinking, then I must exist. And if I exist, then he begins to build an entire philosophy from that. Empiricism, categorical imperative. I think, therefore I am. Cognito ergo sum. Isaac Newton, probably the greatest mind of all time. Fact of the matter is, on that documentary from that I showed, that I put in the assignments list, from that documentary of the top 100 people of the last 1,000 years, Isaac Newton is number 2 behind our good friend Johann Gutenberg. And Isaac Newton, interesting young character. Isaac Newton threatened to kill his stepfather, a very jealous intellectual person. He beat up some kid who wrote a better paper than he did. In his spare time, get this, in his spare time, Isaac Newton invented calculus, kind of like, this is cool. And he invented calculus. How many of you can do calculus? I can't do calculus. Calculus was a thing that persuaded me not to be a math major. I can't make sense of the square root of -1. I'm sorry, But he was a professor of math and physics and came up with the 3 laws of motion. And what are they? All objects have a mass every action has an equal and opposite reaction. An object at rest tends to stay at rest. Object in motion tends to stay in motion. All objects have a mass. I know. The other one was all objects have an attraction for every other object. And the strength of that attraction is based upon that object's size and mass. Yeah. And then he came up with, and according to the legend, he was sitting under a tree one day and got hit in the head by an apple. Rather not. He came up with the law of universal gravitation, which he put into a book called Principia. Every object has an attraction for every other object. Although Albert Einstein will come along 300 years later and actually discredit that idea. Not lying, yeah. Albert Einstein, you see, Isaac Newton said that gravitation works as a straight line. Isaac Newton said that gravitation works as a straight line. Albert Einstein proved that it works as a curve. What does that mean? I don't know. But yeah. Finally, the age of reason, though, begins with the declaration by Newton of the law of universal gravitation, 1687, and ends with the French Revolution of 1789. What is that? Well, get rid of that. No. I'm going to save that. Forgive me. Where was I? Now I'm confused. Uh, there. I'm about to stop anyway. So, yeah, the Age of Reason begins with the declaration by Newton of the law of universal gravitation and ends with the French Revolution of 1789. Should you remember those dates? Will you be asked? Will I ask you for them on a test? No, absolutely not. But you need a ballpark. So you're looking at about 100 years, which begins with Isaac Newton publishing the law of universal gravitation, ends with the beginning of the French Revolution. And this is called the Age of Reason. And I'm going to stop here and we'll pick up with that tomorrow. And